The title is Hyperloop, Rethinking Long-Distance Travel Through Architecture, Urban Design, and Human Experience. So starting off, when air travel was first conceived, it was a luxurious experience. The architecture and design was manifesting a celebration of a journey, the excitement and anticipation of what it could bring, and spontaneity that it allowed. Can we say the same thing today? When I think of a long-distance travel, I think of series of queues, lines, procedures, gridlocks that our body has to go through. We crowd and wait for our turn. We are lined up, stripped, examined, checked, screened, searched, sorted, documented, stamped, and finally shipped. A process pretty similar to the one our luggage goes through, or any industrial process, assembly line, or organization of a shipping center. When I think of travel, I see lines after lines of people congregating in a very large container, which does not respond and often ignores the human body and human experience. So we're left to our own devices, and we have to find a way to adapt to the surrounding, or improvise. But what if things could be different? In 2014, Craig Hodgetts, David Ross, and me, with 25 students, embarked on a design research journey to investigate a new transportation system called Hyperloop. That research was in collaboration with Hyperloop transportation technology. At that time, all we knew was the white paper released by Elon Musk. It was our first point of reference. It contained some information about the technology, but it also rose a lot of questions. So how do we even start thinking about a bullet traveling with the speed of 760 miles per hour, carrying 28 passengers in an enclosed vacuum tube with intervals of every 30 seconds, completely seamless, on-the-go system with no lines, queues, or gridlocks, a system that is environmentally friendly, self-powered, and completely quiet for the cost of only $20 per ticket? For some, it may seem like a dream or a story from a science fiction novel, but for us, it was a serious endeavor. What I'm going to show you are just few pages of the book that we put together as a resource for further design and prototyping. We looked at everything, from the history of travel by camel to travel across the continent, in order to understand the collapse of time and distance introduced by new modes of transportation. We looked at the existing infrastructure, the right-of-way that could become part of Hyperloop right-of-way, and the consequences of our current modes of transportation on the environment. But we also speculated that on creating a nationwide Hyperloop network for which we studied demographics, population density, economic growth of cities, that could allow us to connect people and economies in a meaningful way. Here we're looking at one scenario of connecting mega regions first, and then expanding the system, rather than just randomly pairing up cities. We also took a look at topography and obstacles that the terrain of urban environment could cause. Since we're achieving high speeds, the level change both in horizontal and vertical direction would be noticeable to human experience. So we established radiuses and elevations gained for safe and pleasant travel for the route. Another scale to look at was an urban scale, where we speculated on the location of Hyperloop station within the city. It's interesting that in 1834, it took 2 days for people to travel from downtown Los Angeles to the beach of Santa Monica. But now we could reach 3 cities separated by 300 miles within 30 minutes. You can imagine to work downtown LA and go for lunch in San Francisco and come back within an hour and a half, or go to Vegas for a late-night show and come back before your bedtime. But of course, there are challenges to consider, such as importance of solving the last mile. If it takes 45 minutes to get from your home to Hyperloop station, but only 30 minutes to go from there to San Francisco, the system doesn't make any sense. So the students were proposing an integrated system that could allow to be picked up from home by autonomous shuttle and drop you off by station door. Or another proposal that suggested that mini Hyperloop is implemented within a larger metro area, so people from different neighborhoods could already get access to Hyperloop system and be transported to the main station in downtown LA, from which they will take off at the high speeds. And the station itself has to be rethought and reorganized. From the beginning, the thought was to create smooth circulation and seamless transition through security system. The idea was also not to worry if you miss your capsule, as there were always to be another one. The station is supposed to function similarly to a subway station. We consider circulation in the station that would carry more than 3,300 passengers per hour. And we realized that in order to make one capsule leave the station every 30 seconds, we need 4 bays for arrival and 4 bays for departure. That would give you 2 minutes to board all passengers. And we also ran different scenarios on luggage handling by deploying Amazon Kiva robots that would carry your bags right to the cabin without you needing to carry it. Ergonomic seating positions were at questions. We wanted it to be safe, comfortable experience. Understanding the sidelines, retractable seating, and spacing had immediate repercussion on the capsule size. And the capsule size had an immediate effect on the tube size and the radius, which in return manifested itself in the construction costs. So do we need a bathroom or not in the capsule? Do we have individual seats or combined? And of course, calculating all possible ways of boarding, from gullwing access to one side door or front or back door of the capsule and so on. The next steps was to prototype the stations and infrastructure. Here you see 2 departure zones and 2 arrival zones within a turntable, allowing the capsules to turn and get back to the pressurized condition. This is how the system could potentially work in this fast-forward animation. This was just one of many ideas that the students had. And this one is one of the most compact stations, where the capsules were made out of 2 components: outer pressurized shell and inner cartridge containing individual Kiva robot-powered seats. The individual seats were able to travel independently, and they could leave as they leave the airlock and travel through the station, potentially dropping you off at the bus station all the way at the end. Here the cartridge comes out and the individual seats. Some people could be de-embarked, and the seats also could continue to follow through the station. Arriving at the exit of the building. And eventually, once we had the prototypes, we situated the station on LA River in downtown, bordering Boyle Heights neighborhood, and thinking of the impact of such a station on its surrounding. The students were proposing farmers market where the fresh goods could be delivered from farms by Hyperloop and sold in the station, or creating public space for local people to enjoy the waterfront or everyday activities. All that comprehensive study and speculation had only one goal: to design a new travel experience. The one very different from what we go through now, but the one that we can truly enjoy. Thank you. Questions? Yes. Of course, depending probably on the country that would be implemented, there would be definitely different regulations, but yes. But the idea is to remove all possible gridlocks on the way to create kind of a seamless experience with already the technology that is existing and facial recognition and many others that could allow for that to be part of the system.
Along those lines, you mentioned 3,300 passengers per what time? What was it?
Per day? Sorry, it was 4 years. So but the numbers, I think, when we were looking at it, it was similar to some of the medium-sized airports already.
I think you said per hour.
Yeah.
But my question was, did that include security checks in that analysis?
Yeah, it was including everybody on the station.
Okay, so everyone had to go through an X-ray or something like that?
Yes. Any more questions? Otherwise,
Just curious, do you know why this immersive experience is not present in the current airplanes? I mean, because this looks really cool and we all would like to do that, but airplanes are pretty much the same.
Well, that's true, but airplanes also still have windows, which I think gives a different sense for people in terms of kind of not feeling so claustrophobic. So I don't feel like the airplanes have such a big need to accommodate for thinking about overcoming that.
Just in preparation for this,
Yeah.
I mean, companies could actually
Implement that. Yes, actually there are proposals for airplanes that would have similar technology and immersive experience. Okay. All right, one last question. We have to move on. Yes, please, sorry. Yes, please.
How can you create a station and like a system of dealing with pods that are arriving in the port and you don't even know yet? So we don't know how many So how can you just design the station without this that doesn't exist?
So this is exactly what we were looking at, because even for us, for even just consideration, and not just technology, but just interior consideration of what the travel should be, every inch had an immediate impact on the entire system, not just the station, but the pylons and the tubes and everything. So that's true. Yes, we don't know yet what it would make sense, but for every company that at least we're collaborating with, there are also other benchmarks they have to meet in terms of making this system financially working. So you have to start with something. And of course, as we go on and know more, the system can adopt, but already you will have certain solutions